All right, guys. So I'm going to start if you two have questions. Hey, Jameson, specifically since you all are here. And then anything else, once we're done with you guys, then I can just keep going over the rest of the questions that I'll record for you guys to watch later. So, Kara, we'll start with you. Do you have any specific questions you want us to start with here?
Yeah, for number 6,
Okay.
I don't know like how to do it.
Yep, no worries. Oh, yes, these are difficult. All right. So for number 6, let me comment on this one. All right, so for number 6, basically, so we need to graph this in the calculator. And I know that's a little bit hard to read, but there under y equals, all right, we would put negative e to the x squared. So you're going to have to do multiple exponents there and then minus 4. Because what happens when you graph all of this is it crosses at 0, -5, like here's the vertex, and then it's just a parabola that goes like this, okay? So graphing it first, though, is super important, making sure that's correct. Now, as x goes to infinity, just means that we're going to the right. As x goes to negative infinity, just means that we're going to the left. So basically, you're wanting to tell me, what does the graph do as it goes right? What does the graph do as it goes left? All right, so looking over here on the right, what is the graph doing? The graph is going down. And so how do we represent down? With negative infinity. Okay, over here on the left, what is the graph doing? Again, it's going down. And how do we represent down? With negative infinity. So that's why this here is our answer, because we're saying as x goes to the left, the graph is going down. And let me erase this so I can put that. We're saying as we go to the left, the graph is going down. And then we're also saying as we go to the right, the graph is going down. So do you see how we're using each of those symbols? Does that make sense, guys?
Yeah.
Okay, so just realizing that the first one is talking about left or right, and then the second symbol is talking about up or down. Okay, does that make sense? That was a hard one. Anything else, Kara?
Number 9. Yeah,
number 9. All right. How much more money? And let me get all your formulas. And you guys can use all your equations on the test. Okay, so just FYI for that. Those are all there in Google Classroom under your test. So for number 9, we have how much more money. Oh, so we're going to have to compare. So how much more money is earned in 5 years if 3,000 is invested at 5% compounded continuously rather than compounded annually? All right, so because they're asking for more, you're going to have to do 2 equations, and then you're going to have to compare. So for compounded continuously, then we want to make sure that you use your PERT formula. So A equals P times E to the RT, okay? So I'm just going to plug in P for principal, would be 3,000 times E. The rate is 5%, so we just have to make sure we make that into a decimal, and I'm going to zoom in here. So 0.05, and then that's the time. Let's see. Okay, they don't give us time. Oh, in 5 years, they do. Perfect. 5. Okay, so that's it for my compounded continuously formula. All right, so let me put all of that in. 3,000 times E to the power of 0.05 times 5. All right, so I end up with, and they say to the nearest cent, 3852.08. All right, so this is how much money I make if I compound continuously. And again, this formula, the PERT formula, just comes from our formula sheet, and making sure that you see that word continuously and take that hint to use that PERT formula. All right, so that word continuously, super important. Now for the second one, if it's compounded annually, we're going to have a totally separate formula. A equals P 1 plus R over M to the N, okay? Because remember, if it's compounded annually, that means 1 time per year, all right? So now to fill this in, My principal is still $3,000. That's still what I'm investing. My rate is still 0.05. It's still 5%. This letter M, okay, there in the denominator, is how many times it's compounded a year. If it's compounded annually, I just put 1. And then this letter N is the total number of compounds. So if it's compounded for 5 years and 1 time a year, so we put 5 there. All right, so I'm going to go ahead, put all of that right into my calculator. 3,000 parentheses 1 plus, don't forget, this gets an extra set of parentheses, okay? So 1 plus parentheses 0.05 divided by 1 to the 5th, and I get 3828.84. All right, so notice my compounded continuously makes more money, right? It's 38.52 versus 38.28, but now I can just subtract those. All right, and then I end up with 23.23. Make sense?
Mm-hmm.
Yep, so it's just a matter of you have to set up both, and they are different equations, and then subtracting your final answers.
That was good. Okay.
Yep. Jameson, do you have one? A specific one, or are you just kind of here for all of them?
Like, what's it called? That one problem with the F negative one. You know what I'm talking about? Where
The
it's like
inverse?
solve. Yeah. How do I do that?
All right, let's scroll down.
Forget which one that
Not
was.
sure what number. Yep, no worries. We'll kind of scroll here until we find it. There we go.
Yeah.
All right, so 24. So looking at inverse here in question number 24. And this one's a lot of work, so I'm going to try to give myself some room here. All right, guys. So this one's question number 24, looking for the inverse, which is a really good question to ask about because you can't graph it. So the ones that you can't graph that you have to do all the algebra are definitely going to be more work. So the first thing we do is instead of f of x, I just replace it with y. Remember, this notation always represents the inverse, the f to the negative 1. And how do we find inverse? We switch x and y. So I'm going to go ahead and swap places. So I'm now going to have x equals 3 times log base 7 of y minus 1. Now, you still want to solve for y. Once we do the switch, the whole goal is still to solve for y. All right? So the first thing that we want to do is we want to get rid of this 3 in front. So I'm just going to divide it out. Divide both sides by 3. So now I have x divided by 3 equals log base 7 of y minus 1. Now at that point, I'm going to rewrite this. It's in log form, and I want to put it in exponential form. So whatever is the base of my log becomes the base of the exponent. So I'm going to have 7. Whatever's on the other side of the equal sign becomes my exponent. So 7 to the power of x divided by 3 equals, and then whatever you're taking the log of goes on the other side of the equal sign here. So equals y minus 1. Okay, so now I'm actually almost done. If I want to get the y alone, the only thing left is add 1 to both sides, and I end up with 7 to the power of x divided by 3 plus 1 equals y. And so that's my final answer, and that's how we get that. Make sense, Jameson?
Yeah.
So it's not like they're super hard, but the steps are tricky to remember.
Yeah.
Like if you don't practice them, it's not just gonna like fall into your head. You definitely have to know your steps. Do you guys have another one specifically? Just because I know you both are both here. Kara, Jameson.
Let me look through mine because I don't know I forgot where I put the paper down, but I like from the pictures.
Yeah, no worries. Keep looking. Kara, do you have a specific problem?
For 25. So.
Yep, perfect. And we're right here. All right, so for our decimals, and again, this one has to do with the comparison. So that's what's going to get you there. So one sound measures 150 decibels, the other sound is 110. How much more intense is the louder sound than the quieter sound? So our decibel scale, again, we're going to have to set up 2. Okay, Kara? So I'm going to be using, and I'll just put the formula over here so we have more space. D equals 10 times log of I over I sub 0. Now remember, for decibels, I sub 0 is always And they even tell you down here on the question number 26, I sub 0 is 10 negative 12. So it's always 10 negative 12. So that's just something, make sure you guys know, because it's not going to show up in your formula sheet. And for example, in question number 26, they tell you, but they might not always tell you. All right. So we're just going to have set one up for each one. So we're going to have 150 equals 10 times log, I don't know the intensity, over 10 to the negative 12. Let me zoom in a little. All right. So now for my second equation, I have decibels of 110. So 110 equals 10 times log to the I over 10 to the negative 12. So does that setup at least make sense? You see our original formula, you see why we plugged everything in. That letter D stands for decibel. So basically we have to work backwards. That's what makes this trickier. So the first thing I'm going to do, divide everything by 10. So I end up with 15 equals log I over 10 to the negative 12. And so now we have to rewrite this. In order to solve for I, we have to go from logarithmic form to exponential form. So if there's no base there, what's the default base?
10.
Perfect. Yep. So I'm going to put 10 to the power of 15 equals I over 10 to the negative 12. Okay. So now I'm just going to do 10 to the power of 15. I'm going to do both sides, right? Times negative 12 to get rid of it. So times 10 to the negative 12. So 10 to the power of 15 times 10 to the power of negative 12. And I end up with intensity of 1000. Okay, so for the 150 decibels, my intensity is 1000. But now I still need to finish the intensity for my 110 decimals. So I'm going to do the same steps. Let's divide both sides by 10. I end up with 11 equals log I over 10 to the negative 12. I'm going to rewrite this. So log base 10. So I put 10 to the power of 11 equals I over 10 to the negative 12. I multiply both sides by 10 to the negative 12 to cancel that out. 10 to the power of 11 times 10 to the power of negative 12 gives me 0.1. So my intensity here is 0.1, okay? But they're asking how much more intense, and look at all your answers. They all have times. So what do we do to find that with those two numbers? Divide, okay? Because basically they're asking how many times more, how much do you have to multiply by? So when you divide 1000 divided by 0.1, that's where you get your 10,000 from. Does that make sense?
Yes.
Okay, yeah, so you're just struggling with the comparison ones, which are the hard ones. So that's good. You know, you have the basics. It's just once you kind of kick it up to that next level.
Yeah.
Jameson, did you find another one while you were looking? You're still on mute, so if you're telling us something, we can't hear you.
Yeah, sorry. I was saying, I guess 39.
All right, number 39. So use a graphing utility to approximate to 2 decimal places any solutions of the equations. All right, so don't let this throw you guys off in the interval, okay? They're just saying, right, our solutions are gonna be where they intersect. And basically they're just saying from 0 to 1, we just wanna see if they intersect in that little space, okay? Starting at x is 0, ending at x is 1. So let me graph it first on my calculator to see what it looks like before I try to get into all this crazy stuff. ln of x plus 5, or I'm sorry, plus e plus e to the power of 5 to the x. All right, so this, guys, and this is a graphing one in the calculator. This goes in y1, all right? So this is a calculator graphing one. This is gonna go in y2, all right? So I just put in my y1, now I'm gonna put my 0 into y2. I'm gonna hit graph. All right, and I get a really tricky kind of graph. I'm actually going to show it just here on the screen really quickly. Do you guys see that red line there at the bottom? That's the 0. And then we see the blue. Okay, so it almost looks like they don't intersect, right? So that would mean no answer. But obviously, we see here all of them are answers, and they're really small. Okay, so I'm going to change my window to an X scale just from 0 to 1. And that's kind of what they're telling you here, the scale, just to go from 0 to 1. Okay, so in my calculator here on the scale, I just did my window X minimum of 0, X maximum of 1. All right, I'm going to hit graph. And notice now I'm getting something that's much, much easier to see. All right, and I can see where that red and blue line now intersect. All right, so I'm gonna go to second trace. So second trace, intersect. The first curve, I'm gonna pick my blue one. The second curve, pick the red one. You just hit guess, enter, and they tell me they intersect at X equals 0.1372. So they say round to the nearest second decimal place. So that's why that 3 becomes the 4.14. Make sense?
Yeah.
So it's just a graphing one, graph Y1, graph 2. So don't let the scale throw you off, because I know stuff like this, the wording is new to you guys. You probably haven't seen tons of that, but don't let it throw you off. It's just like extra information kind of thing.
Right.
What else, guys? Kara, you got one?
Number 28.
Number 28. And have your next one on deck for us, okay, Jameson?
All right.
So this is another comparison one. Okay, Kara, your favorite. So how many times stronger is the earthquake? 8.6 Richter versus 7 Richter, okay? So our Richter scale is M equals 2/3 times log of E over E sub 0, okay? And so just like our I sub 0, all right, I'm gonna show you guys here in 27 because they match up. Just how I sub 0 for decibel levels always has a default number, E sub 0 on the Richter scale is always 10 to the 440, okay? Every single time. So again, just make sure you guys are aware of that, because some problems will show you, like they're in problem 27, but some problems won't, all right? So just make sure that you're aware of that. E to the sub 0 is always 10 to the 440. So we're gonna set this up similar to how we did the decibel level one. So magnitude is my 8.6 or my 7, all right? So I'm gonna plug those in and then I'm gonna work backwards. So I'm gonna put 8.6 equals 2/3 times log of E over 10 to the 440. All right, and over here I'm gonna set this up as 7 equals 2/3 times log of E over 10 to the 440. All right, now we're gonna work backwards pretty much the same way we did for the decibel level. So this 2/3, I'm just gonna deal with it kind of as 1, and I'm gonna divide both sides by 2/3. So divide both sides by 2/3, 8.6 divided by 2/3. Make sure, guys, when you put that in the calculator, the 2/3 is in parentheses. If it's not, you can get a different answer. So I end up with 12.9 equals log E over 10 to the 440. Again, now I'm gonna rewrite it. Since there's no base there, the default base is 10. So I'm gonna put 10 to the power of 12.9 equals E over 10 to the 440. To solve for E, I multiply both sides times 10 to the 440. So times 10 to the 440. So I have 10 to the power of 12.9 times 10 to the power of 440. So my 8.6 ends up with a 1. And this is going to be, I'll show you guys that way you guys understand when you see it. Do you see how it has that letter E there at the end? It has like 1.99999 and then E to the 17. Okay, guys. So it looks like this. It looks like 1.995 e to the 17. Remember, this is scientific notation. All right. So that means 1.995 times 10 to the power of 17. All right. So that's what that means. So I'm going to leave it like that because we don't have to worry about it until the end when we go to compare. All right. So that's the strength of my first earthquake. That's 8.6. Now let's find the strength of my 7 earthquake. Again, we're going to follow the same steps. Leave this 2/3 as a fraction, deal with it together, divide both sides by 2/3. So I get 7 divided by 2/3, making sure that's in parentheses. I get 10.5 equals log e over 10 to the 440. I'm going to rewrite this now. So I'm going to have base 10 to the 10.5 equals e over 10 to the 440. Keep scanning. Sorry, guys. To the 440. Perfect. So then to get that e alone, I multiply both sides by 10 to the 440. Here on the right, they cancel out. Here on the left, times 10 to the 440. So let's see, 10 to the 10.5 times 10 to the 440. So this intensity now for my 7, or the strength for my 7 earthquake, would be 7.943 times 10 to the power of 14. Okay? So there we go. But again, they're asking how many times stronger. So times implies multiplication. So to find the answer, what do I need to do?
Divide.
Exactly, because I'm going to do the opposite operation. So I'm going to divide. Now this is the bigger one. How do we know that? Because it comes from 8.6. All right. The bigger Richter scale is always going to be the stronger earthquake. All right. So we take that 1.995 times 10 to the 17th, and then I just divide by the 7.943 times 10 to the 14th. And then when I divide, that's how I end up with the 251.9.
All right.
And again, these are hard. So you guys are picking difficult ones. They are harder. Jameson, how you doing? Any other questions? Special problems you want to go over?
Yeah, what's it called? Number 13.
Okay. 13, the wolf population. All right, so the wolf population is expected to increase. They give you the curve. N is the number of wolves after T years. What is the limiting value? So another word for limiting value would just be like the asymptote.
Oh, okay.
All right, and they're just using that language limiting value to get you guys ready for calculus. So if you guys were to take calculus after this, you would start seeing more of that language of limiting values, but it's the same thing as an asymptote. So all we're going to do is put this into Y1 in the calculator. All right, this is just a calculator problem. But then obviously instead of T, we can't use T. So what are we going to use?
The X.
The X, right? So in Y1 in the calculator, we would put 43 divided by 1 plus 5e to the negative 0.25, and then we would put X there. All right, so let me put that in here really quickly. 43 divided by 1 plus 5 e to the power of negative 0.25 x. All right, now notice what your options are. We go from no limiting value to 1, 5, 43. So make sure you have a big window. So I'm just going to do windows of 50 all the way around. So my window, I'm going to do 50 y max, negative 50 y min, 50 x max, negative 50 x min. Okay, so that's what I'm going to make my window there. And then my scale, remember you always want to skip count by 10% of that. So I'm going to skip count by 5s, 5, 10, 50, and then negative 50, 50. All right, so let me show you guys again just really quickly here on the calculator, just in case, right? Notice x min negative 50 to 50, scale of 5. Y min negative 50 to 50, scale of 5. All right, so I'm going to hit enter. Okay, and then here's the graph we get. And remember, they're asking for the limited value, which is just another way to say asymptote. So do you guys see how there at the top, we have the asymptote right up here?
Mm-hmm.
Okay, guys, right up there, we have the asymptote that it's going. And if you wanted to hit trace, you could. Now, here's a great question, and let me draw this kind of on here so you guys can see. Because the graph goes like this. Why do I care about this asymptote and not that one? The key word here is increase. Okay, so that's why this part on the left, we don't really care about because we're saying the wolf population is going to be increasing. So that's why we only look there at the right. And so if you then trace, so you could just trace right along that line. And if you keep going to the right, you're going to see y equals 42.7, 42.8. So you're going to see there that it's approaching 43. Okay, does that make sense? So the probably the language of that threw you off, the idea of the limiting value, because it's really just looking for the asymptote, which would be 43. You got another one for us, Kara?
Yeah, I have one more. Number
Yeah.
40.
40, woohoo, all the way to the end. So here we go. All right, assume that we model population P by using the equation P equals P sub 0, e to the RT, where P sub 0 is the population at time T, R is the continuous annual growth rate, T is the time in years. How many years will it take for the population to triple, assuming an annual growth rate of 1.5? All right, so what we're gonna have to do here is plug in values. All right, so first of all, let's make sure that we start with the right equation. They already tell us this. All right, remember that P by itself is the ending amount. P sub 0 is the starting amount. That's why it has the 0 there, because you start at 0. All right, like when we're counting kind of thing. All right, so they don't tell us what the population is. So let's pick random numbers. Let's pick easy numbers, right? If it's tripling, let's say my ending population is 15, because then what would my beginning population be?
5.
Perfect. Okay, guys, make sense? Because if you start at 5 and it triples, you end up at 15. You guys can pick any numbers you want. You could have picked 1 and 3, right? But this one was just an easy one as well. Times E, they tell us the rate is 1.5. So again, move that decimal place over twice. So it's going to be 0.015. And then how many years? That's what we're looking for, right? So that means that T, that time, is going to be my variable X. We could have left it as T if we wanted to, all right? So now to solve, the first thing we do, divide both sides by 5. So I end up with 3 equals E to the power of 0.015x. Now what do we have to do? Solve for an exponent. Nicely done. Yep, so we rewrite this. So I'm gonna do log base. Remember, whatever's the base of my exponent is what I make the base of the log. So log base E of 3 equals 0.015x. Okay, that E would be the base. Now keep in mind, if I have log base E, that's the same thing as saying ln 3 equals 0.015x, right? Because log base E is natural log, which is ln. So now to solve for x, I just divide both sides by 0.015. So I'm just going to put ln 3 equals divided by 0.015. And so that's how I get x equals 73.24, which is hopefully our answer there. Yep, 73. round to the nearest year. Okay, so it's setting it up and working backwards.
Mhm.
Right, Kara? So if you're good, Kara, you're free to go. If you want to stick around and just kind of watch, see what Jameson asks, you're free to do that too, okay? I just don't want you guys to feel like you're hostage or anything.
Yeah.
Jameson, you have another one?
Yeah, number 5. Oh yeah, also, Ms. G, you remember Bella Falcone?
Yeah.
She says hi, by the way.
Oh, tell her I
Like,
say hi. No, of course. Miss Falcone. Where is she now?
uh, uh, like, where is she, like, physically?
Yeah,
She's
is she
she's in
still around
she's in,
South
she's in
Florida?
Mexico. No,
Oh,
she's in
she's in
Mexico.
Mexico. Okay then. So number 5, Jameson, you said, right?
Yep.
All right, so this is just a graphing one. All right, so you're gonna put this into Y1 in the calculator, this into Y2, and then we want to see where they intersect. All right, Jameson?
Mhm.
Make sense? So
Yeah.
I don't think you want me to go through the actual graphing, right?
Yeah. No, that's
Yeah,
fine.
because that I
I
know
grab,
you
I
can
grab.
do.
It's just I just calculate where they intersect, and that's it. Right.
Yep, that's it. Second trace intersect. A little
Yeah.
tip, don't forget, like for the 7 minus x, make sure you put that in parentheses. Yep, exactly. But it's just a
Because I was looking,
graphing one.
I was like, do I got to distribute or something? And that
Nope,
confused me.
just a graphing, see where they intersect. Either one of you, Kara, Jameson, you got another one for us?
I think I'm
I'm
good for
good.
now. Let me like
All
look
right.
over it one more time. Make
No,
sure.
awesome, guys. Thank you. I'm glad you guys were here. Okay, I'm probably gonna do a quick like walkthrough once you guys leave of the rest of the questions. So this video will be up in Google Classroom probably in like 45 minutes. So if you guys
All
want
right.
to, you can go back and like just see me talk through saying like exactly like, okay, number 4 is graphing, number 7's this, that kind of thing. Okay, guys?
All right.
Good.
Perfect.
Thank you for being
you.
here. All right, guys. I'll
Bye.
see y'all tomorrow.
Bye.
All right, guys, so I'm going to go through the questions that we did not do in depth, just really quickly talking about the idea behind solving them. I'm not going to go through every single step of the problems, but for example, number 1, this is just a graphing question, okay? So making sure we put that into the calculator, 9 to the negative x, and then making sure you guys pick the correct graph. For number 2, as far as simplifying, what we do here in number 2, since these have the same base and we have division going on, then you want to subtract the exponents. Okay, guys? So keep your base of 5, but then you're going to have 2 minus x minus 6 plus 3x. And notice how I'm putting them in parentheses. So make sure we distribute. So I would have 5 to the 2 minus x minus 6 minus 3x. Now you just combine your like terms. 2 minus 6 gives me negative 4. Negative x minus 3x gives me negative 4x. And so that's how I get my answer. Okay, guys? For number 3, for simplification, all of this you guys can just put right into your calculator, okay? Please just make sure that you are careful with your 4 to the negative 1/2. So for example, in the calculator, you'd put parentheses, 16 cubed, 4 to the parentheses, negative 1/2, put another parentheses squared. Okay, guys? So just make sure you're really careful with that. Now, if you put all of that into the calculator, you're gonna end up with this number, 4194304. Obviously, that's not any of your answers. So what do? You put all your answers into the calculator as well, okay? 3 to the power of 17 gives me 129140163. So obviously that's not the same as the answer I'm looking for, so I can cross it out. So you just kind of keep working your way down through that, okay? For number 4, graph using the transformations, okay? So all we do, put this in the calculator, y1 equals e to the power of x plus 2, all right? Make sure, since all of this is the exponent, that you put all of that in parentheses, all right? And then you just pick your correct graph. That's it. So scroll down, make sure you pick your correct graph. We talked about 5 and 6 already. For number 7, I think is a little more straightforward for you guys as well. Notice number 7 is just a graphing problem. All right, just please make sure you have to put the numerator in parentheses, put your denominator in parentheses. So in the calculator, you would put y1 equals 3 to the power of x plus 4 to the negative x, parentheses, divided by 5. Okay, for the x-intercept, all right, we do second trace. And remember, x-intercepts are the same thing as zeros. So for the x-intercept, you do second trace, and then you find the zeros. For the y-intercept, this is when x equals 0. So you can either trace and just go on that y-axis to see where the intercept is, or you can also go to second table, all right? So for the y-intercept, if you wanted to go to second table and see where x equals 0, what's that y-intercept? You can do that as well. All right. Down here for number 8, we have Mr. Rhodes wanting to buy Ella a car. Like I said earlier, your formula sheet is in Google Classroom under the test tab, and you are allowed to use that formula sheet tomorrow and Tuesday for the test. So he wants to buy her a car when she gets her license. How much money should be invested now? Compounded continuously. So just making sure that we're using the right formula. Compounded continuously is the PERT formula, okay? How much money should be invested now? We don't know. We want to end up with 20,000. So how you should set this up is 20,000 equals P times E to the 0.03, remember make that 3% into a decimal, times 16. Okay guys, makes sense? So that's how you should set this up. And then you would just divide both sides by that entire number. Find E to the 0.03 times 16 and just divide both sides by that. We've talked about how to solve number 9. Let's talk here number 10. Number 10, there's really no math to do. It's just making sure that you know your half-life formula, I believe this is. Let's see. Assume the number of bacteria doubles. Oh, so your doubling formula, right? So just look at that formula sheet. Make sure you have your doubling formula, which is A equals A sub 0 times 2 to the T divided by D. Okay? So that's how we end up with that. Just notice they tell you it doubles every half hour. So for D, what they put was 30, because notice we're going in minutes, and 1/2 hour equals 30 minutes. So just be cautious of that, because there's not really math to do here in number 10. It's just understanding those little nuances. They're going to tell you half an hour, and you have to understand to translate that into 30 minutes. Number 11 is along those same lines. Notice now we're just working with half-life. So you have A equals A sub 0 times 1/2 to the time divided by the half-life. If the substance has a half-life of 18 hours, that's what you plug in there for H. You start with 500. How much is left at the end of 2 weeks? All right. So no, what you want to be careful with as well here is you're working in hours and weeks. You cannot have that. You have to be in the same unit. So how do I turn 2 weeks into hours? 2 weeks is 14 days. So I would do 14 times 24 hours in a day. 14 times 24 gives me 336 hours. So please be careful, guys. You have to make sure you're in the same units. So how you would set this up is A equals, we start with 500 times 1/2. The total time T is 336, and then the half-life is 18. So this is what you would put into the calculator, and that's how we get the 0.0012. All right. For question number 12, looking at Newton's law of cooling, they give you here this entire equation. Assume that ice cream is below freezing at 25 degrees Fahrenheit. If it's placed in a bowl where the temperature is 70 degrees Fahrenheit and K equals 0.1, what is the temperature of the ice cream after 1 hour in the bowl? All right, so T is the temperature. So all I'm going to be doing here, guys, is plugging in. T equals T of M, look at your problem. It's placed in an environment of constant temperature T of M. So what environment is this ice cream placed in? It's placed in a bowl where the temperature is 70. So T of M is going to be 70. T sub 0, all right, initially at temperature T sub 0. So what is my ice cream initially at? 25. So I would put 25 minus, notice here's another T sub M, which is going to be 70. Then I have times E to the negative. I'm told what K is. K is 0.1. So to the negative 0.1, and then T is the time. What is the temperature after 1 hour? Okay, so there for time, I'm just going to put 1 hour. And once I go ahead and put all of that, that's how I end up with 29 degrees. So notice, guys, all of this is just putting this into the calculator. All right, it's just reading the problem, understanding what they're asking you. What does T sub 0 represent? What does T sub M represent? We did 13 already. I think 14 you guys will be really good with. I mean, worst case scenario, guys, if you totally forget everything and blank out, you can put these into the calculator, but they're pretty simple, right? Log base 4 and the 4 cross out. That's why we're just left with 6. The 9 and the log 9 cross out. That's why we're just left with 2. Down here, again, this is just putting straight into the calculator. Remember that ln is natural log, okay? And that natural log is next to the number 4 on the calculator, okay? So you literally just put that right into the calculator. Same thing here. Finding the log is just calculator work. All right, here, this is calculator work as well. What you have to do is rewrite it. Remember, default base for the log is 10. So really, we're saying log base 10 of x equals 0.1582. So to rewrite it, I would put 10 to the power of 0.1582 equals x. So then you can just put this right into the calculator to find your answer for x. Okay, guys? So there's 18. For number 19, solving for x, okay? Again, you can just rewrite this if you wanted to. All right, so we would have x to the power of -3 equals 15.625. All right, now since this is a negative exponent, I want to get rid of that. So I multiply times -1 times -1 to the exponent. All right, so I end up with x cubed equals 15.625 to the power of -1. Okay, so when I multiply the -1, I'm multiplying the exponent. So now how do I get x alone? I cube root. And remember, where is that cube root found? It's in the calculator under the math button. Okay, guys? So down here for number 20, same thing. Solving for x, you just want to rewrite this. You take the base, 6 to the power of 5/7 equals x. So now it's just a matter of putting that in the calculator. Okay, here for number 21, you can cross out the 5 and the log 5, and you just end up with x equals 12. And remember, part 1 of the test on Monday pretty much lines up with questions 1 through 20, okay? Part 2 of the test on Tuesday leans more towards questions 21 through 40. All right, question number 2, evaluate to 3 decimal places. Remember, this ln is just natural log, so this is just straight up, put it into the calculator, okay? To be extra careful, just put your parentheses, right? Parentheses ln 0.25 divided by parentheses 0.3. All right, it's always better to have an extra set of parentheses than to be missing one. We've talked about 23 already, 25. All right, for 26, the decibel level of sound. And I know all the work is up here from 25, but let's look at number 26. It's a little bit more straightforward because all we do is plug in, okay? I have my decibel formula. Decibel equals 10 times log of the intensity over I sub 0. But they tell me, and this is always the case, I sub 0 is always 10 to the negative 12. So all we would do is 10 times log. The conversation is 3.16 times 10 to the negative 6. And then I would just put this over 10 to the negative 12. Okay, guys? So now you have something that you can put all of this right into the calculator and get your answer. All right? So 26 is pretty straightforward. It's just plugging in and getting your answer. We did 27 already. We did 28. 29, again, a little bit more straightforward because we're just plugging in. All right? They're giving you here the formula to use, the velocity formula. All right? They tell you the weight ratio is 14.5. The exhaust velocity is 3.21. And they told you earlier in the problem, C is the exhaust velocity. So I'm going to have 3.21 times ln. The WT over WB is 14.5. All right. And what is the velocity of burnout? So all we do now is just plug that in right into the calculator. Okay, guys? So again, they're giving us all the information that we need. It's just a matter of plugging it in. So this just goes right into the calculator, and that's how you get your final answer. For number 30, the solutions, the pH, so acidic or base. All right. Again, notice they're giving you the formula. All right. They tell you the hydrogen ion concentration is 3 times 10 to the third. So all you're going to do equals negative log of 3 times 10 to the third. That's it. So just put this into the calculator, and that's how you get your negative 3.5. All right. For question number 31, solving for x, whenever you have x in the exponent, you have to rewrite it into log form, right? That's the whole point of doing log this chapter, to solve when there's an exponent. So I'm going to do log base e, whatever's the base of the exponent becomes the base of the log, of 0.36 equals negative 0.07x. So to get x alone, divide both sides by negative 0.07. So divide this whole thing by negative 0.07. So all of this you can just put right into the calculator. Okay, guys, and you get 14.6. For number 32, solve exactly. Okay, so if you are subtracting logs, you can be dividing. All right, so I'm going to combine these into 1. Log of 2x squared over 4x equals 1, okay? And so now you could rewrite this if you wanted to. Honestly, the algebra is going to be a little bit longer. So my recommendation for this one, guys, would be just to graph. Because you can obviously solve this algebraically, but it's going to be a little bit shorter if you graph this. If you put all of this into y1 in the calculator, and you put this into y2, then you just want to see where they intersect. But please keep in mind, look at the answer options that you have. Make your window big enough. So if the biggest answer choice is 40, I would make your window at least 50 all the way around. Okay, so that means going from negative 50 to 50, y min negative 50, y max of 50. All right, so make sure you have a big enough window. Down here for number 33, all right, this one's pretty simple to solve algebraically. If my base is 10, I would just put 10 to the third equals 4x minus 5. So we get 1,000 equals 4x minus 5, right? We add 5 to both sides. So now I have 1005 equals 4x. We divide by 4. And so that's how we get 1005 over 4 for the final answer. For number 34, solving. Again, when x is in the exponent, that's when we need log form. So I'd put log base 2.3 of 46 equals x. Now remember, when you have a weird base, you can find that under math. Okay, if you guys go to math and then scroll down, you do have to scroll down a good amount. I think it's like the 10th option. Then there's like a log any base. All right, and you can choose that. For number 35, solve. All right, e to the 4.5x minus 30. So the first thing I'm going to do is add 30 to both sides. I get e to the 4.5x equals 30. Now I'm going to rewrite this. Log base e of 30 equals 4.5x. So now I just divide both sides by 4.5. So I put all of that into the calculator, and that's how I get 0.756. Okay, guys? For number 36, again, we're just solving. The first thing you want to do is divide both sides by 213. So negative 165 divided by 213 gives us negative 0.7746 equals e to the power of 3 to the x. How do we solve when there's an x in the exponent? I'm going to do log base e of negative 0.7746 equals 3 to the x. To get x alone, I divide both sides by 3. So to solve for x, I just put all of that into the calculator. Okay, I end up with no solution. The reason for that is because I'm taking a log of a negative number. And you cannot take a log of a negative number. So you can still put this into the calculator, but what's going to happen is you're going to get error. Okay, guys? So still put it in, because obviously you're not always going to get error. But in this case, when there's no solution, it's because you got an error. Okay? For number 37, solve. Again, these are a little bit longer. So when you have the logs split up, I would recommend to graph. So put this in y1 equals, put this in y2 equals, and then again, you want to see where they intersect. So go to second trace, intersect, and see where that takes place. For number 38, this is absolutely another graphing one. All right, so you would put all of this in y1 equals, all of this in y2 equals, see where they intersect. Please, guys, look at my answer options. These are all really small choices. So your x min and your x max, you want to make them little so that you can see. Okay, maybe from like 0 to 5, like an x min of 0 and x max of 5. We did 39 together and we did 40 together. All right, so hopefully that helps. All right, guys, if you have any questions still, feel free to put them in the comments and I will help you guys out some more. So thanks for joining us, and I'll see you tomorrow, Monday at 3:15. I will send out the link. Okay, so make sure you send you check your email at 3:15 Monday afternoon for part 1, 3:15 Tuesday afternoon for part 2.